Have you ever wondered why statistical tests are crucial in research? They are the backbone, the silent heroes behind the breakthroughs and discoveries. They're the tools that allow researchers to sift through mountains of data and find meaningful patterns, trends, and relationships. Statistical tests provide a scientific and standardized method to analyze data. They help to validate or refute hypotheses, thereby driving the research forward. These tests are like detectives, uncovering the truth from a pool of information. They measure relationships between variables, helping researchers understand how one thing affects another. Moreover, statistical tests are vital in making predictions. They help researchers forecast future trends and outcomes based on current data. Imagine being able to predict the success of a new drug or the impact of a policy change. That's the power of statistical tests. Understanding the importance of statistical tests is the first step to grasp the essence of any research. So, let's dive deeper into this fascinating world of numbers and patterns. Dive into the realm of descriptive statistics, the foundation of any data analysis. As we venture into the world of research, we find ourselves surrounded by data. But how do we make sense of it all? That's where descriptive statistics come in, helping us summarize, describe, and understand the characteristics of this data. Let's start with measures of central tendency. These are essentially the center points of our data. The mean, often known as the average, is calculated by adding up all the numbers and then dividing by the total number of values. The median, on the other hand, is the middle value when the data is arranged in ascending or descending order. Finally, the mode is the value that appears most frequently in our dataset. Then we move on to measures of variability. These tell us about the spread of our data. The range is the difference between the highest and lowest values. Variance is a measure of how much the data varies from the mean, and the standard deviation, probably one of the most crucial measures of variability, is the square root of variance. It tells us how much individual data points deviate from the mean. Lastly, we have measures of frequency. These give us an insight into the count of specific data points or categories. Proportions tell us the fraction of the total for a particular category, while percentages are simply proportions multiplied by 100. So, why are these important? Well, descriptive statistics provide us with a basic overview of our data. They allow us to identify patterns, trends, and even potential outliers. They are the starting point of our analytical journey, helping us make sense of the data before we delve into more complex statistical tests and analyses. In the grand scheme of research, especially in fields like psychology, economics, sociology, and many more, descriptive statistics are not just numbers, but a narrative. They tell the story of the data, providing the first glimpse into what the data might be trying to communicate. And so, with an understanding of the mean, median, mode, range, variance, standard deviation, proportions, and percentages, we can confidently say, descriptive statistics providing the basic overview of the data is where the analytical journey begins. Now, let's explore inferential statistics, the tool to make generalizations about a population. Inferential statistics is like a magic key, unlocking the door to informed conclusions and predictions about entire populations, based on a humble sample of data. It's the very essence of making the unseen seen. Consider t-tests. They're like the diplomatic negotiators of the statistical world, comparing the means of two groups of data to determine if there's a significant difference. So if you're wrestling with two different data groups and need to know if their means are truly distinct, call in a t-test. Next, we have analysis of variance, or ANOVA. This method is a bit like a referee at a sports event, comparing the means of three or more groups of data to judge if there's a significant difference. If you've got more than two teams in the game, an ANOVA is your go-to. Now, let's talk about chi-square tests. They're the detectives of the statistical realm, testing for associations between categorical variables. If you've got a hunch about a relationship between variables, a chi-square test can help confirm or debunk your theory. Let's not forget about correlation, the measure of the strength and direction of a relationship between two variables. Picture it as a weather vane, pointing out the direction and intensity of the wind, except in this case, the wind is your variables. Finally, we have regression analysis. Think of it as your crystal ball, predicting the value of one variable based on the value of another. It's a way of saying, if this, then probably that, bringing a level of forecasting to your research. Each of these statistical tools has its unique strengths, but they all share a common purpose: to draw valid conclusions from the data and make predictions about the wider population. Inferential statistics enables us to draw conclusions and make predictions about the population. What if the data doesn't meet certain assumptions? Enter non-parametric tests. Non-parametric tests are the unsung heroes of statistical analysis. They step up when the data doesn't fit the mold of normality or other assumptions required by parametric tests. While they may not have the power of their parametric counterparts, they shine in their robustness to violations of assumptions. Let's dive into some common non-parametric tests. First up is the Wilcoxon rank sum test. This is used when you want to compare the means of two groups of data, but your data is not normally distributed, or you have outliers that could skew your results. Next up is the Kruskal-Wallis test. This is like the Wilcoxon rank sum test's big sibling. It's used when you want to compare the means of three or more groups of data. And again, it's a great choice when your data does not meet the assumptions of parametric tests. Then we have the Mann-Whitney U test. This test compares the medians, not means, of two groups of data. It's particularly useful when dealing with ordinal data, where the values can be ranked but the differences between them are not uniform. The Friedman test is another tool in our non-parametric toolbox. It's used to compare the medians of three or more groups of data. This test is commonly used in repeated measures design where the same subjects are tested under different conditions. Finally, we have Spearman's rank correlation. This test measures the strength and direction of the relationship between two variables, but unlike Pearson's correlation, it does not require the data to be normally distributed. It's a go-to when dealing with ordinal data or when the relationship between variables is not linear. So, there you have it. Non-parametric tests robust to violations of assumptions are the safety net in statistical analysis. They might not be the first tools you reach for, but they are indispensable when your data doesn't play by the rules. When dealing with multiple variables, multivariate tests come into play. Multivariate tests, as the name suggests, involve the analysis of multiple variables simultaneously. These tests are more complex than univariate tests, but the effort is worth it. They can provide a more comprehensive understanding of the data, revealing patterns and relationships that might not be apparent when looking at variables one by one. Let's start with factor analysis. It's like a detective tool for researchers. Factor analysis is used to identify underlying patterns in a large set of variables. It's like condensing a long, complicated story into a few key themes. This is especially useful when dealing with large datasets where the sheer number of variables can be overwhelming. Next, we have structural equation modeling, often known by its acronym SEM. This method is used to test hypotheses about the relationships between multiple variables. It's like a high-tech string board, connecting variables together to see how they interact. SEM can handle complex models with multiple dependent variables, mediating variables, and latent variables, making it a powerful tool for researchers. Finally, let's discuss cluster analysis. Picture a room full of different objects. Cluster analysis is like a tidy-up tool, grouping similar observations together based on their characteristics. This method is often used in market research to identify segments of consumers, but it can also be applied in many other fields. Each of these multivariate tests has its own strengths and applications, and the choice of which to use will depend on your specific research question and the nature of your data. Remember, these are just tools in your research toolkit. The most important thing is to understand your data and your research question, and then choose the tools that will best help you answer that question. Multivariate tests provide a comprehensive understanding of the data when multiple variables are involved. They are essential tools in the world of research, helping to unveil the intricate, interconnected nature of the world around us. Let's recap the key points about statistical tests. Descriptive statistics provide a basic overview of your data, identifying patterns and trends through measures of central tendency, variability, and frequency. Meanwhile, inferential statistics allow you to make generalizations about a population from a sample, testing hypotheses and drawing conclusions about variable relationships. Here, you'll encounter t-tests, ANOVA, chi-square tests, correlation, and regression analysis. If your data doesn't meet the assumptions of parametric tests, you'll turn to non-parametric tests. Though less powerful, they are robust against assumption violations. These include the Wilcoxon-Rank sum test, Kruskal-Wallis test, Mann-Whitney U-test, Friedman test, and Spearman's rank correlation. Lastly, multivariate tests analyze relationships between multiple variables simultaneously, offering a comprehensive understanding of your data. Factor analysis, structural equation modeling, and cluster analysis fall under this category. Remember, the choice of which statistical test to use will depend on your specific research question and the type of data collected. Happy analyzing! Before we wrap up, we'd like to encourage you to share this video with your friends and colleagues if you found it helpful. You can do so by clicking on the share button below the video, which will give you options to share on various social media platforms. We regularly post informative videos on research and statistics, so don't forget to subscribe to our channel to stay updated. You can subscribe by clicking on the subscribe button. Thank you for watching. Remember, the world of research is vast and ever-evolving, but don't be intimidated. Stay curious, keep learning, and you'll master it in no time.